Hello, good morning everyone. My name is Scott Platt and I am the Regional Sales Manager for Vermason. I currently cover the UK and Ireland. Thank you for attending the Vermason ESD Basics Seminar this morning. This PowerPoint is going to go through the basics of ESD and ESD awareness. So an introduction here, ESD control training. So per the IEC, European Standard 61340-5-1, the training plan, initial and recurrent ESD awareness and prevention training shall be provided to all personnel. All organisations should have ESD training in place. After this seminar, Kathleen will be following up with each of you and to organise our ESD awareness guide to be sent to each of you, which you can use following this for your training programme. So safety. Safety first, concern when working around high voltage. As important as ESD control is, it is of secondary importance compared to an employee safety. So when working with any voltages over 250 VAC, ESD personnel should not be grounding themselves, and that's with the use of wrist straps, ESD footwear and garments. The written ESD control plan should be in accordance with IEC 61340-5-1. An ESD control program that has been established using the technical limits required by this standard will minimize ESD-related damage to devices that have an ESD sensitivity greater than or equal to 100 V human body module, as determined through testing using IEC 60749-26. As I said on the previous slide, it is important that all organizations have ESD training in place. It's also important to have this repeated annually, so refresher training to each of your operators. Anyone that is working with ESD sensitive items should have this refresher training, and this should be recorded and documented within the company's written ESD control program. So static electricity or electrostatic charge. So this is defined as electric charge at rest. All materials tribo charge. So this is when two surfaces contact then separate. Some electrons move or are given up in the other surface, this causes an imbalance. Electrons are negative and protons as positive. As you can see on each of the two images there, you have your plus and minus signs on when the two surfaces are making contact, which is causing this imbalance. So all materials tribocharge. So some examples: opening a non-ESD standard plastic bag, combing of your hair, unrolling tape. You can build up charge walking on a carpet, sliding across your car seat. The charge will be greater when weather, it will depend on whether if it's cold and dry. And ESD is when the charge moves. So charge generation or tribocharging. So when two materials make contact and then are separated, a transfer of electrons from one material to the other may take place. The amount of static electricity generated depends upon the material subjected to contact or separation, friction, the area of contact or separation, and the relative humidity of the environment. At lower humidity, when the environment is drier, charge generation will increase. And common plastics generally will create the greatest static charges. Electrostatic discharge. So this is if two items are at different electrostatic charge levels. As they approach one another, a spark or electrostatic discharge, which is ESD, can occur. This rapid spontaneous transfer of electrostatic charge can generate heat and melt circuitry in electronic components. So examples of electrostatic discharge or ESD, any daily activities, we will create charges on ourselves with clothes rubbing together, and say walking on carpet, opening the plastic bags. But the biggest one we're all familiar with is lightning, which is in a much bigger scale. And a zap from your door, we've all had this at some stage where we've walked across a carpet, then gone to touch the doorknob, the door handle, and we've received the zap, which is that ESD event taking place. So ESD is the hidden enemy in a high-tech manufacturing environment because you can't see it, and at lower levels you can't feel it. So this is a photo of an ESD arcing from finger to a component. This is not a computer simulator. The technician in this photo was connected to a small magneto. And you can see there on that photo the ESD event taking place. So a scanning electron micrograph image of the ESD damage after the removal of the capacitor. This is at magnification at 10,500 times. So again, it goes back to the previous slide where you can't see ESD damage with the naked eye. So we have two types of materials. We have conductors, and in conductors electrical current flows easily. So that means we can be grounded. So examples, metals, carbon, and of course ourselves, humans, people. Materials that are called dissipative are conductors. They are able to remove electrostatic charges to ground. The resistance of dissipative materials is the higher portion of the conductive range. And the other type of material we have are insulators or non-conductors. In insulators, electrical current does not flow easily, so these items cannot be grounded. Some examples are plastics, glass, dry air. Insulators, such as the plastic cup in the image, these will hold the charge, and as where they cannot be grounded, they cannot conduct the charge away. So insulators in an ESD, an EPA environment, these can be very harmful. And we will talk a bit later on in this PowerPoint on if insulators are necessary in your process, in how we can control these from holding and generating high charges. So some typical electrostatic voltages. So walking across a carpet, as you can see, you could generate up to 35,000 volts. Walking over an untreated vinyl floor, a non-ESD floor, anything from 250 to 12,000 volts. Standard vinyl envelopes used for work instructions. You may have these on your workbench where the operators will follow instructions, procedures. These can generate anything between 600 and 7,000 volts. And a worker at a bench can actually generate up to 6,000 volts. And unwinding of regular tape, anything between 9,000 and 15,000 volts. And as you can see at the bottom there, the higher number is usually generated at a lower humidity. So of course the effects of ESD, people discharge frequently, as I said, but we don't see ESD damage and we don't always tend to feel it. But to feel a discharge, it must be at about 2000 volts. This is when we have generated 2000 volts or above, is when you will feel that static shock. Sliding across your car seat to open the door, opening the door handle on a door. If you've generated anything at 2000 volts and above, that is when you could potentially feel that discharge and that static shock. But then when it comes to sensitive items, in electronics, even less than 100 volts could potentially damage a component. And this is why today it's important that we go through these ESD basics, and your company guys using ESD understand the importance of grounding themselves out and having good controls in your EPA. ESD is the hidden enemy, so consider all electronic components ESD sensitive. Your program may identify classification or sensitivity to ESD damage. In today's world, the newer electronic components, as they're getting smaller and they're getting more powerful, this is increasing their sensitivity to ESD, so they're becoming less voltage can potentially damage them. And again, ESD damage cannot be seen by the naked eye. So this is an optical photo of a large integrated circuit board which has actually experienced ESD damage. If you see in the top middle of the top of the photo, where the pin is noted by the arrow, is where ESD damage has taken place. So now we have on that same circuit board, we've now zoomed in at 400 times. Oh, sorry about that. I'll just go back to the page. Right, so back to this photo. As you see at the top there, ESD damage has been experienced, and where the pin is at the top of the page, the same point, this is now the same board. We are zoomed in at 400 times. The damage is noted as the fuzz at the end of the arrow, as you can see there on that image. Again, it's still quite hard to tell that ESD damage has taken place. And now with that same board, we have now zoomed in at 500 times magnification using a scanning electron micrograph, and now you can see the ESD damage. The overlaying glass vegetation has been removed, and the surface has been decorated to show the ESD damage. So types of ESD device damage that can take place: catastrophic failures. So this is inspection. When it comes to inspection, it is able to detect the failure. And a latent defect. So a component that has been wounded, but has passed various inspection phases as good. So with them two in mind, latent defects will be more costly. And as to why, is because, as you see there, they've passed various different stages of inspection. The product has then actually gone out into the field and is with the customer, and it may work for a while, but then suddenly you will start to have issues, problems with that product, which will then lead to returns, warranty costs, and lower customer satisfaction, which could lead them to look elsewhere. So repair costs, they increase if a failure is detected later. So if it isn't found at inspection stages and then is out in the field. So this is just a study that indicated the repair cost to be. So, so for example here you have a $10 device. That same device now is on a board which equals to $100. That $10 device on a board and now in a full system is $1,000. So when that $10 device and that total system fails out in the field, it could cost your company, your organization, anything up to $10,000 just because the wounded component wasn't found at the testing stages. So catastrophic failures are detected during inspection, but components with latent defects will pass as good, which then could lead to failures later on down the line. So latent defects are the most frustrating because they pass inspection as good. They may fail later on in the field. This then causes equipment downtime. It could potentially cost costly field repair work, and this could impact your customer and their satisfaction in your product. So the hidden enemy, ESD damage may occur. It cannot be felt, it cannot be seen, and it can't always be detected through normal inspection procedures. So like germs, we very much compare ESD to sterilization in the medical industry, in hospitals. You wouldn't want to be operated on in a non-controlled environment. They sterilize everything from the tools. They're always sterilizing and cleaning after they've touched each tool and done each operation. And it's the same with ESD. So again, you would never consider having surgery in a contaminated operating room, and you should never handle electronic assemblies without taking the right protective measures against ESD. So now we're going to go into more of the ESD control and the ESD control program. So first off, it's important that you identify your ESD, your EPA protected area, that you identify all ESD sensitive items, you provide ESD control training to all your operators. The basics of ESD control is to ground conductors, so remove or neutralize insulators using ionizers, and shield ESDS sensitive items with, when stored or transported outside the EPA area. So ground conductors, including people, so personal grounding devices, we lead with two types. So it's wrist straps. When using wrist straps, it's important they are snug on the skin, that they ain't loose. It's also important that they're clean, as dirt can deteriorate the properties within the wristband, and that the cord is connected to ground. Foot grounders, heel grounders, when worn, the grounding tab is inserted into the shoe and is under the foot correctly. It's important that foot grounders are worn on both feet and that they're in contact with the ESD floor at all times. You don't want an operator wearing a heel grounder, and if they are seated at the workbench, they've then got their feet up on the chair legs or on the bench legs, because then that they will not be then making contact with the ESD floor. So daily testing of your personal grounding devices. So it's important that you do daily testing on your wrist straps. This will verify that they're working and that the operator can then go onto the shop floor to then handle and work on sensitive devices. Or if you're using continuous monitorers or are looking into continuous monitors, there will be no daily testing required, as it's in the name. When the operator is at the bench, they will be continuously monitored. Their wrist strap will be continuously monitored while they're working at the bench, and would alarm if there was any break or any high charges while they're at the bench. Foot grounders, again, have to be tested daily. We do recommend that you do test both your wrist straps and foot grounders at minimum of twice a day. So maybe once first thing in the morning, then once after lunch. And again, it's to verify that they work, so the operator can then go into the EPA area. So workstation grounding devices. Dissipative work surfaces, they must be grounded via ground cord to a common ground point, as you can see in that diagram there. And the same with conductive floor mats. If you have these in place, it's important that these are also grounded via the ground cord to a common ground point. So it's important with your work surfaces that you clean and maintain these using only an ESD specified cleaner. Dissipative work surfaces. So it's important to keep these surfaces clean. Dirt will act as an insulator over time and damage the properties in your work surfaces, and this is including your floor. So it's very important that to maintain these, you clean these using an ESD cleaner, as standard regular cleaners can contain a silicone, which is also an insulator. So over time, you would just damage the properties of your work surfaces. So again, yeah, it's important that any bench mats, flooring you have in place, you use a ESD cleaner on both of them. So as we discussed earlier on insulators, we went through that you can't ground insulators and they can hold charges and also generate high charges. So if insulators are part of your process, there is a way to neutralize these, and this is via ionization. So insulators, they cannot be grounded. So to neutralize these, we would use ionizations. Ionizer airflow will then flood the area with ions, positive and negative ions, which will then neutralize the charge in that insulator. So it's important when using ionizers that the airflow is directed to the work area, to where the sensitive item is being worked on. Ionizers produce positive and negatively charged ions. And ionizations can reduce static charges on an insulator or isolated conductor. So the types of ionizers We have benchtop ionizers, which would be placed over the workbench. Neutralizing air nozzles or handguns, these would be connected to an airline. Oh, sorry, benchtop ionizers, sorry, the first point, benchtop ionizers, these would be placed on the bench. Overhead ionizers, these would go above the bench. So all these types of ionizers will neutralize charges on insulators and isolated conductors. Ionizers do require periodic cleaning of the emitter points. Because if this isn't done, it can potentially then go out of balance, a voltage offset that then could then potentially charge the items and not neutralize them. So it's important that when using ionizers, you do have a maintenance plan in place and you regularly check the emitter points and clean them. So shielding of ESD sensitive items outside a protected area. So you have all the controls in place inside the EPA. Operators are grounded using wrist straps, using footwear. You may have both in place. Any insulators in the area that are not needed are not on the bench. Any that are used, you're using ionizers to control the charge. It's also important outside the area that you shield these items using the correct packaging and storage. So the Faraday day cage effect charges to be conducted on the surface of the conductor. As charges repel, these charges will then rest on the exterior. So ways of controlling sensitive items outside the EPA, the most common one is to use closed metallized shielding bags. These can come in open top and Ziploc. If you're using an open top bag, it's important that you fold these over and seal with an ESD warning label or ESD warning tape. Because if these are unsealed with product in the bag, the charge, as you can see there, with the charge hitting the surface, it can then potentially go inside the bag. So it is important that any items outside the sensitive area outside the EPA, they are sealed. And the other option is conductive tote boxes. Again, any product in these tote boxes, it's no good having them in the box without a lid. So just like the shielding bags where they have to be sealed, any sensitive items in a conductive tote box should have a lid on top to keep it closed. And then once brought into the EPA and once the operator is grounded, this is when they then can open up the shielding bag or open up the conductive tote box and then actually handle the sensitive item. So ESD packaging, electrostatic discharge, shield a barrier or enclose that limits the passage of current and alternates an electromagnetic field resulting from electrostatic discharge. So again, ESD bags should be closed and conductive tote boxes, containers have lids in place, especially when outside of the EPA area. And then ESD packaging, only to be opened at an ESD protected workstation by a properly grounded personnel. So protected workstations, an ESD protected workstation is an area that has been established to effectively control electrostatic charges. So again, grounding all conductors, including ourselves, using either wrist straps, footwear or both. Removing all insulators, or if there are any insulators that are in place and are part of the process, you would neutralize these insulators with an ionizer. So best practice is to remove an insulator or change to an ESD version. You will find now that there are many alternative ESD safe versions of many products now. Any day-to-day products that you may need inside your EPA or at the workbench. So ESD garments and gloves. You can get conductive foams, ESD dissipative ring binders and dog wallets. As we said earlier on in this PowerPoint, non-ESD dog wallets can create high charges, so if you have any paperwork in EPA in a non-dog wallet, it could potentially be a risk. So it's important that you swap these out for ESD alternatives. ESD packaging, so boxes, bags, corrugated boxes, anti-static or low charging sellotape, dissipative floor finishes, and various material handling containers. So where in the past they may have been hard to get hold of as an ESD version, it is very common nowadays that there is ESD alternative versions of many products that are needed on a day-to-day basis in the EPA. So your operators working with sensitive items daily are on the front line of fighting the hidden enemy, ESD damage. So it's important that you only allow trained or escorted people into the EPA. It's important that you ground all conductors, including people, at the ESD workstation. It's important that wrist straps and footwear are tested daily. We do recommend a minimum of twice a day, or you use continuous monitors for wrist straps as an alternative. It's important that in your program you have checks to make sure that all grounding cords are connected and haven't been tampered with. To handle unpacked ESDS items only when grounded. So again, don't take anything, don't handle a shielding, a sensitive item without being grounded at a workstation. It's important to keep your wristband snug, your foot grounding tab in the shoe, not having it outside the shoe, and if wearing ESD garments, lab coats, smocks, that they are buttoned up all the way to the top. So if using ionizers, as we touched on earlier, it's important that these are maintained, and if using ionizers, be it benchtop, overhead, or handguns, that the airflow is directed at the sensitive items to flood that area, and to use only shielded packaging for shipping or storing of ESD sensitive items outside the ESD protected area. So you'll see on the Vermason websites, here at Vermason, we are happy to help you verify your ESD controls. This is just a screenshot from the Vermason website page, and as you can see that arrow there, we do actually have a tab under ESD survey. So in this we have a no charge service that we offer to all our customers, where we would come out and actually review and verify your ESD, your EPA area. So yeah, if you're interested in this service, you can find more information under the ESD survey tab, as I've arrowed there in the screenshots. There is actually a form there you can fill out, or if you have any questions regarding the ESD survey service or any of our products, feel free to contact Kathleen, who will be following up with you after this meeting, or contact us at service@vermason.co.uk with any other questions you have, and we'll be happy to help. And that is the end of this morning's seminar. Thank you very much for everyone who has attended, and I look forward to working with you and speaking with all of you in the near future. Thank you very much.